Hello and welcome to the first BCC 2020 video. This is covering question number 1, which is called Skyline. So, a skyline consists of 14 towers as shown. The height of a tower is measured from the bottom of its base to its highest point, including any flagpoles or antennas. If the towers are listed from shortest to tallest, which tower would be 10th in the list? So if we divide the towers through this blue line, we can see that the towers on the left are sorted from shortest to tallest, and the towers on the right are also sorted from shortest to tallest. You may be asking why we don't just compare the objects by visual glance, and this is because this is a computer science contest and we are trying to apply computer science principles and see how they apply in the real world, and we can learn from these principles, and it's just a way that we can learn a lot more, and we see this in visualization. So what is the significance of the fact that the left side is sorted and the right side is sorted? So this is what we call the last step of something called merge sort. So what merge sort is one of the fast ways to sort a list of objects, elements, or things from shortest to tallest, from smallest to largest, or the other way around. Now here's a quick example of how merge sort would work. So merge sort starts off with the initial list of elements. What we first do is we divide this list of elements in half. But since we can't divide the list in elements in half, we can't divide the element 76 in half, we have to divide to the right of 76. Now we have the subset, or the partition, like a part of the original list of 57, 3, and 76. And now we have another part, 29 and 34. So look at the left part first, 57, 3, and 76. Now this isn't just one item, so we have to split it again into 53 and 3 and 76. Now 76 is an individual item, so this one is complete. So now we look at the left side of the left part, which is 57 and 3. Now this isn't one element, so we have to split it again, and since it's even, we can split it down the middle. And we have two elements, 57 and 3, and these are both individual elements, so these two are complete. Now, for the right side, we have 29 and 34, and since this is a group of two elements, we have to split it in half. So we have 29 and 34. Now, we have to merge all of these items together, and that's why it's called merge sort. When we merge them, we compare it and see which the smaller ones go first and the larger ones go after. So here we have 57 and 3. Now we want to merge them together, and we see that 3 is smaller than 57. So 3 would go first, and then 57 would come after. Now we have 3 and 57 being compared to 76. So we take the first element on the left, which is 3, and we take the first element on the right, which is 76. And we see that 3 is smaller than 76. So 3 would go down first. Then we take the second element, because the first element's already been put into the sorted section, and so we have 57 and 76. Now 57 is smaller than 76, so 57 goes down. And then since there's no other elements, 76 goes down. Now if we look at the right, we have 29 and 34. 29 is less than 34, so 29 goes into the sorted, and then 34 goes into sorted. Now we have 3, 57, and 76, and the other element, 29 and 34. 3 has to go down first, because when we compare 3 and 29, 3 is smaller. Now we compare 57 and 29, we see that 29 is smaller, so therefore 29 goes first. And now we compare 34 and 57, and we see that 34 is smaller, so 34 goes down into the sorted list. Now 57 has no other element to be compared with in the right list, so it goes down into the sorted list, and so does 76. And now we have the sorted list, 3, 29, 34, 57, and 76. Now that's a quick demonstration of merge sort. But why is merge sort useful in the real world, and how does it apply to this question? Now, merge sort is very useful in the real world, as when we have large lists of items that we need to sort, merge sort efficiently sorts through these items quickly and effectively. When we have lists of items in the upwards of 10 to the 5, or about 100,000 items, doing a sort just by comparing two elements every time, or just switching elements, would be way too inefficient to quickly do it. But by using merge sort, we can quickly and effectively do this. Now, in this question, this is effectively the last step of a merge sort. It's merging two fully sorted arrays that are sorted from smallest to largest, and we're merging them together to find the 10th shortest item. Now, there's 14 elements, or 14 towers, and we're looking for the 10th shortest. Now, if we go from the other way, so we're going from the right to the left, and we're looking at the tallest towers, that's the 5th tallest, right? So since 5 is smaller than 14, it's much quicker to find the 5th tallest tower instead of finding the 10th shortest tower. And since that's the case, we can look at what 4 towers are taller than it, and then look for the next tallest tower. Now we see that CN tower over here is much taller than anything else. It has the tallest of anything, so you know that's the tallest tower, right? So it's number 1. Now, we see that the next tallest tower would be the one on the very right, this one. And this one's taller than the tower on the left here, so we can confidently say that this is the second tallest tower. Now we look at the next tallest tower on the right and the next tallest tower on the left. Well, the one on the right goes 1, 2, 3, 4, 5. It touches the 5th line. But the one on the left goes 1, 2, 3, 4, 5. It doesn't reach the 5th line. So therefore the one on the right is actually taller than the one on the left. So the one on the right is our 3rd tallest tower. Now the one on our left, compared to the rightmost one that hasn't been known as the tallest one, would be this black tower. And this black tower goes down 1, 2, 3, 4, 5, 6 lines plus a bit. The one on the left side only goes down 5 lines and a bit. So the one on the left would actually be taller than the one on the right. So the one on the left is our 4th tallest tower. Now we look at our peace tower and the black tower. Now the peace tower goes down 1, 2, 3, 4, 5, 6, 7, and a bit. Now the right one goes down 6 and a bit. So that means this one is taller, the black tower is taller than the peace tower. And so that means the black tower is our 5th tallest tower, which is our 10th shortest tower, which is exactly what we're looking for. We're looking for from shortest to tallest, what is the 10th tower? And so we know that the black tower is the shortest tower, is the 10th shortest tower, the 5th tallest. So we can confidently say that answer A is the correct answer to this problem. Now, if you know any of the names of these towers, be sure to leave them down in the comments. I'll be looking at them. And if you liked this video and how I solved it for you, and if you want to see more content, be sure to hit the notification bell after you subscribe, like the video, comment down below, and if you have anything else that you would like me to cover, also leave that down in the comments. I'll be reading through those, and thank you very much for watching, and I'll see you next time.